So now we are having the assignment 4, where first we are going to see how to implement the GridSearchCv as a reference before we move on to the main assignment. Okay, so now let's see. So as a first step here, we are importing some of the dependencies, mainly from the scikit-learn and the numpy, that we are going to use throughout this notebook. And after importing the dependencies, now we are making our own classification dataset using make_classification that we are importing here from the scikit-learn. So basically, using make_classification, you can create any n-class classification dataset for your task by initializing some of the parameters as shown here. So in our case, we are initializing the number of samples as 10,000 and number of features equal to 2. That means we want the number of data points, or you can say the number of rows in our dataset as 10k, and we want the number of columns or attribute as 2. And after that, we are having two more parameters here, that is number of informative and number of redundant. That simply means that out of these total number of features, how many of them you want to consider as informative features and how many of them you want to consider as redundant features. So redundant features in the sense dependent features, or you can think like linearly combination of other features. Okay, so in this case we don't want any redundant features, that's why here we make it 0, and we want all these features as informative, that's why here we make it 2. And now after that, we are having one more parameter here, that is number of clusters per class. That means that how many cluster you want per your class label. So here we mention 1, that means we want only one cluster per your class. And in the end, we just simply give a random integer value for your random state, so that every time when you just run this code, you will get the same results. Fine. And also one thing you observe here is that here we are not specifying the number of classes. So by default, it will take the value 2. That means it will create a data set for you with 10,000 data points and with 2 features, and the class label is 0 or 1. So it creates a binary class classification data set. But if you want to create a data set for multi-class problem, then you have to add one more parameter here as a number of classes. So for more details, I recommend you please go through the documentation of make_classification from the scikit-learn. Fine. And now once the data set is ready, now we are storing the feature vector into variable x and your class label into variable y. And after that, as a next step, we have to perform the splitting. So for that, here we are using train_test_split that we are importing here. And here we are passing your feature vector x and your class label y. And here we are performing the stratify sampling. So as a result, you will get the 4 set as x train and the corresponding y train, x test and the corresponding y test. Fine. And also you can check the length of your train and the test, that out of 10,000 data points in your data set, we are having 7,500 data points for your train and we are having 2,500 data points for your test. And as we move further, you can also plot the data point from your test data using the scatter plot as shown here, where on the x-axis we have taken your feature value 1 and on the y-axis we have taken your feature value 2nd, and based on the unique values present in your y-test, we are giving the different color maps. For example, in our case, we are having in y-test we are having 2 unique values as 0 and 1. So that's why here you can see we are giving 2 different colors based on the class label it has. So here you can see the yellow and the dark blue. So now coming to the most common question asked by a lot of our students, that what if we want to change the default color as shown here. So for that, what you can do is, the one thing, you can add one more parameter here at color map, and you can mention the color that is already predefined in the methodology. So now when you run this code, now you will see a different color combination with respect to the default one. Okay. And one more thing, that if you want to make a color combination of your choice, so for that you have to add one more variable here as color, where you can specify in a list form the colors of your choice, depends on the unique class label you have. So we are having 2 class label, that's why here we are giving 2 colors. And now you can pass this color variable using matplotlib colors.listed color maps. So now when you run this, now you can see the color combination as red and green. Got it? So now let's move on to the main thing here, where you have to implement the custom GridSearchCv. That means here we are not importing the GridSearchCv from the scikit-learn. Here using the function here we are implementing it. So before I explain you the meaning of each of these lines in this function, so let's try to start the things from here, where we are importing the accuracy score as your performance metric, k-enable classifier as your machine learning model, and we also import warning so that it will ignore any warning while running your code. Fine. And now we are initializing the k neighbors classifier, and we are storing a variable neighbor in this variable, and after that we are initializing in the value of different values of k, because since we know that in k neighbors classifier we have to tune the best, we have to perform the hyperparameter tuning in order to find the best value of k. So that's why here we are defining some range of values on which we want to perform tuning, and we are storing the variable parameters here. And after that we are initializing the number of folds we want, as fold is equal to 3. So that's why here we are performing the k fold cross validation. And now we are calling the function GridSearch that we initialized above, and here we are passing 5 arguments, that is your X train and the corresponding Y train that contains the 7500 data points, and also your classifier that we initialized here, and the parameter value, that means the list form that contains the different values of k, and your number of fold as 3. So now let's move on to the function here. So in this function, at first we are initializing 2 variables as train and the cross validation score, and now here we are having 2 for loops. The first for loop that will iterate over the number of neighbors, the value of k on that list. So initially when you enter this for loop, the value of k is 3. And the second for loop will iterate over the number of folds. So since we initialize the number of fold as 3, so this for loop will run over 0, 1 and 2. So when first time you enter this for loop, the value of j is equal to 0 for the value of k is equal to 3. Got it? So what we are basically doing in this, that for each fold value here, we are randomly selecting 60% of your data points in your X train, and we are considered as it as the train indices, and rest of them we are considered as cross validation indices. So what we are doing is that we are having 7500 data points in your train data. So for each fold value, what we are doing, we are taking 60% of it that we consider as your train data, and the rest 40% we are consider as your cross validation data, such that the intersection between these two sets is 5. That means these both are disjoint sets. Okay. So how to find the random, how to select the randomly 60% of points? So for that, here we initialize one more function, that we are using random.sample. We are taking the 60% of 7500 data points, and we are storing these indices as train and the rest indices as CV indices. And now we are selecting the data points based on these indices as your X train, Y train, X CV and vice. And after that, now we are calling our classifier on the value of k, that is 3 at first time, and we are now fitting on your train and the Y train data, and we are performing prediction on your cross validation and train, and we are calculating the accuracy score. So what basically we are doing here is that for the first time, it will run your first for loop run for the value of k, and your second loop will run over the 3 values of fold, that is 0, 1 and 2. And for each value of fold, we are selecting the 60% of your train indices and as your train data randomly, and rest of them as your cross validation data. So this will be performed for each value of 4. And after that, what we are doing, now we are running your k neighbors classifier with the value of k as 3, and we are fitting on your train data, and we are doing the prediction on both train and cross validate, and we are finding the accuracy score. So for the fold 0, we will get a particular train and the cross validation accuracy, and same for your fold 1, and same for your third fold, that means the with index 0. And in the end, what we are doing is, now we are taking the average of your train accuracy, that is by adding these 3 score and dividing by 3, and your mean of your cross validation accuracies, so that in the end we will get a final train and the cross validation accuracy with respect to the value of k, with respect to the value of k is 3, and by taking the mean of these 3 folds. So these 2 variables that I am showing here is initialized here, and these 2, the value of fold that we are initializing here, and the final train and the cross validation score for particular value of k we initialized here, and by taking the mean here we are using np.mean. So we are returning here this final score, that is train and the CV score that we initialized here, that contains the mean of each value of fold for the particular value of k. Okay. So now you can plot, after that now you can plot the hyperparameter versus accuracy plot that you can see here, where on the x-axis you will take the different values of k, and on the y-axis you just plot the accuracy plot. And now you can see we are having two curves here, the train and the CV curve. So based on these graph, now you have to find the best value of k. So you will get the different graph in your notebook. So how you can find this depend on the graph you have, how you can find the best value of k. So for that, the one thing is you have to check that on your CV curve at which value of k you are getting the highest value of accuracy. So you can see here in this curve we are having this, or let's say this. These are 2 points where we are getting almost highest value of accuracy as compared to any other value of k. And the second point you have to check that the gap between your train and your CV curve should be small. So you can see as with respect to this plot as compared to this one, we are having a less gap with a value of k as here 90 as respect to the value is k. So that's why we have taken the value of, we found the best value of k as 19 using these two curves. Got it? So now what you have to do is, now you have to plot the decision boundary with this function that we initialized here, and we are now running your k neighbors classifier with that best value of k that we found using that graph, and now we are fitting on your train data and we are simply plotting the decision boundary as you can see here. Got it? Okay.